Good morning, ladies and gentlemen, and good morning to our session hosts, Professors Concepcion and La Peña. Thank you for inviting me to present at this convention. I have chosen to present to you a UP Manila College of Medicine program called SIBOL. It stands for Surgical Innovation and Biotechnology Laboratory and has for its objective the innovation, creation, and manufacture of medical and surgical devices using locally sourced materials. The primary objective of which is to address the inadequacy of locally made healthcare equipment and devices. I have nothing to disclose in relation to this presentation. Neither do I have any business interests associated with any of the SIBOL projects, except for my involvement as primary investigator in one of the projects. This is a simple outline of my talk. It is not so much a presentation of a research question, but more a description of our journey to set up a biomedical program at the UP Manila. I will then show you how we responded to COVID, and finally, I will share with you reflections and lessons we continue to learn about such a program. Let me start off with this slide, which rings and resonates every single day of our professional lives. Almost all medical devices present in developing countries have been designed for use in industrialized countries. Consequently, they are often unaffordable and are maladapted to low-resource settings. Take a look at all of these different health devices and technologies, even those sorely needed during this pandemic, including ventilators and PPE. Everything is imported. Is it any wonder why we always do not have enough? Why we always cannot afford them? And worse, why the spare parts are never available? So why don't we make them? Yes, we can, but we need the engineers and the clinicians to work together to design the devices. However, while we do have individual clinicians and engineers doing this, there are to date few such mature institutional linkages between clinicians and engineers, whether in government or the private sector. This lack of collaboration between engineers, scientists, and clinicians is a situation we also see at the University of the Philippines, where two great masses of brain cells, one in Diliman, the engineers and scientists, and one in Manila, the clinicians and allied medical staff, hardly ever meet, seemingly separated by the deep divide of the Great Pasig River. How many times, after being frustrated by the unavailability of some medical equipment in the hospital, have healthcare workers in the UP Manila thought about or actually assembled a rudimentary backyard solution, only to shelve it because of the lack of an integral engineering component or the lack of its understanding? Engineers in UP Diliman, on the other hand, awakened to some of the greatest eureka solutions to health problems, only to find out the healthcare provider does not need that earth-shaking creation after all. Sometime in March of 2019, then UP Diliman TTBDO, or Technology Transfer and Business Development Office Director Michay Pasha, sent to the UP Manila a list of engineering projects requiring clinical trials. Together with NIH Executive Director Eva Cutionco de la Paz, we set up what we called a click meeting, conversations leading to innovations and collaborations. This marked the start of the construction of a bridge across the Pasig. We had a teleconference, the UP Diliman group on one side and the UP Manila group on the other side. The meeting was a success. We matched some of the engineers and scientists from the UP Diliman side to the clinicians on the UP Manila side, so they could continue from conversations into collaborations. And then we decided to cross the bridge to UP Diliman, finding out in the process that we didn't, after all, need a visa to enter that republic. We made a presentation entitled Getting to Know Each Other at the meeting sponsored by the UP Diliman TTBDO at the College of Engineering to a large group of engineer and scientist researchers. This was a list of topics we brought to the audience. Let me show you a problem which received a lot of question and attention. The upper right-hand picture shows you a common injury at the PGH, where the skin and soft tissues of the leg are completely ripped off in a vehicular accident. A good method to cover this defect is using what we call vacuum-assisted closure, or VAC, VAC for short. There are now many different VAC apparatuses which are portable and convenient for patient use. These commercially available devices are imported and are unaffordable for the PGH patient. While they seem simple to make, we clinicians don't know how to. And the best we can do is shown on the right lower picture. The entire construct on the leg connected to a vacuum provided by a wall suction, which is why in the PGH it is more appropriately called wall suction assisted closure, or WASAC. The engineers must have taken pity on this WASAC method of closure because this project received endless questions and suggestions. It was a good meeting, and we took it one step further. We now arrange for the UP Diliman engineers and scientists to cross the bridge and visit the PGH, so they could see for themselves the problems they were creating solutions for. So 2 months after the initial click, we had visitors from UP Diliman at the hospital. These are pictures showing the chair of the operating room welcoming them, and the bottom pictures show how the engineers studied equipment and how they visited patients who were hooked up to the now infamous WASAC. As a result of this encounter, 4 projects were undertaken, all collaborations between UP Manila clinicians and UP Diliman engineers and scientists. We submitted these projects to the PCHRD together with a project for the establishment of an office and laboratory for research and development. In the process, the program was christened SIBOL, a Tagalog term meaning germination, and which appropriately stood for Surgical Innovation and Biotechnology Laboratory. By the end of the year, we presented the program to the Execom of the OST and were gifted for Christmas with a grant for SIBOL. But alas, no good run lasts for long. Just before the signing of the MOA between the DOST and the UP Manila, we were overtaken by COVID-19. And things happened in quick succession, and before we knew it, we were on complete lockdown. By the end of the month, what started as the Ides of March had seen an endless litany of friends and colleague frontliners whose lives had ended too soon. These personal tragedies, together with the spirit of bayanihan, made SIBOL ask what it could do in the face of this viral onslaught. We had no MOA, we had no money, we had no infrastructure, we had no equipment. Hey, but hold on, we had a reason for being. And most importantly, we had Viber and we had Zoom. So SIBOL convened March 20, and 3 months later, on June 20th, we had 11 ongoing projects. We divided our thrusts into 3: PPE, disinfection, and telemonitoring, basically to protect, to disinfect, and to distance. Here you see the 3 teams and 11 projects with the principal and co-investigators, always 1 clinician and 1 engineer or scientist. Under the PPE team, we have the reusable mask, the PAPR, which stands for Powered Air Purifying Respirator, and the coveralls. Under the disinfection team, we have the Sanipod, the negative pressure room, clean intubate, PPE disinfection, and AeroSafe. And under the telemonitoring team, we have the telepresence, telemetry, and e-step. I'm unable to show as much as I would like to because of non-disclosure agreements. Here on the left upper picture, you see the Zoom meeting for the PAPR group. The left lower picture shows you products of the telemonitoring group. The right upper picture shows you the efficacy testing for the Sanipod, a sanitation chamber for healthcare workers in full PPEs. And the right lower picture is that of the group working on the e-stethoscope. Most of these projects have applied to the DOST PCHRD for funding. But while funds have not yet arrived, prototypes and expenditures have been shouldered by private donations. In this last part of my talk, I will share with you the little experience we have had over the past 1.5 years, getting SIBOL going and handling the COVID task force. What has SIBOL achieved in its infancy year? We have been able to initiate conversations and collaborations. And these collaborations have been both horizontal and vertical. Through work and by word of mouth, SIBOL has begun to draw interest from both students and faculty. Importantly, we have highlighted a multidisciplinary team approach, and in a short span of time, we have been able to produce several prototypes. What strengths have we discovered in the process? Like everyone has always said, the expertise and the capability are there. We have available mentors, especially those who have been successful abroad and who now share their knowledge and experiences with us. Individually, some of us have access to different support networks. And finally, not enough can be said about the robust existing research infrastructure in the university. We recognize our weaknesses too, and I have classified our weaknesses into those within our institution and those outside of our institution. Many of us have a poor comprehension of the process of translational research. Available mentors are a strength, but because there are not many who have the experience we look for, it can also be a weakness. Linkage with industry is strong, is starting, but is not yet robust. The Manila and Diliman campuses have no previous official collaborations on similar programs, which can serve as a template for us. Outside of the institution, we find there's a lack of a roadmap for requirements and compliance regulations for different technologies we want to develop. There's similarly no ready list of government agencies or offices in charge of standards for procedures and products. Finally, we were extremely handicapped by not being able to procure materials for our prototypes or access testing machines during lockdown. As part of the weaknesses, we need to talk about finances. From initiation of meetings to finally receiving MOA and budget, the fastest it took for some of the projects was 3 to 4 months. We commend the DOST for expediting the process, and we are grateful. However, a raging pandemic waits for no one, and if it were not for our private donors, we would never have been able to come up with our prototypes. As the cliche goes, there is always opportunity in crisis. We are seeing the opportunity to get different experts together from both engineering and science departments on the one hand, and medical and allied medical departments on the other, all with a single goal of fighting COVID. But we cannot rely on passion alone for long. We need to institutionalize this collaboration. And to make things much easier for future projects, we need to institutionalize the process and print out the roadmaps. What threats do we perceive pervade the innovation environment? We fear the continued difficulty in accessing necessary materials and equipment during quarantine. We are well aware of bureaucratic delays in government procedures, despite the officials doing their best to expedite matters. Because of the difficulty of the entire process, some of the researchers may very well give up soon after the prototype is made, especially when they see how much faster prototypes and final products are deployed by private institutions and industry, even if some of these do not really meet standards. From our experience, we can see that innovation processes such as these require more government support. I end my ruminations on a high note, but also on a very cautious note, because our curve continues to rise. There are still a myriad COVID problems needing solutions. And even when COVID-19 has waned, the problems and inadequacies of Philippine healthcare will continue, and they can overwhelm us. SIBOL senses the coming storm, and it has taken root and has begun the process of germination. Allow me to acknowledge these institutions and individuals, and most of all, the extreme efforts of all the members of our SIBOL teams. Thank you very much for listening.